Alright, so I think this is recording, at least I hope it is. We're looking at Skill Packet 5 exponential and logarithmic functions. Um, in this Skill 5F, we've got logarithmic equations that we want to solve. We need to know the properties of logarithms and stuff, and actually also I guess I should include the definition of a logarithm because we need to oftentimes convert a log equation to exponential form in order for us to solve it. We look at this and we say, well, we don't have two logs equal to each other, so I really can't use the idea of a one-to-one function, or none of my properties allows me to manipulate this or change the form of this. But if I do recognize that this is in log form, I can change it to exponential form. So I could also rewrite, since a logarithm is an exponent, I could recognize that this 2, another way to write the number 2 is log base 7 of 49, not 47. But sometimes that could be even more confusing, I think, for students. I think probably the better solution is to just recognize that this is exponential or log form and change it to exponential form, that the base is 7, a logarithm equals an exponent, that's 2, and that equals to this x plus 3 quantity squared. So that's a quadratic equation. It'll have two solutions. However, sometimes our solutions are extraneous. But in this case, no matter what x is, we know that x plus 3, when you square it, it is going to be a positive value. So we're going to have two answers here, and I believe, neither one of them, well, I know that neither one of them will be extraneous. So let's get this quadratic equation into standard form. 7 squared is 49. Now on the right hand side, this is not x squared plus 9. You have to multiply x plus 3 times x plus 3. So you get x squared plus 6x plus 9. If you need to create a table over on the side, or FOIL, or however you prefer to multiply binomials, this is what you should get. So the standard form for a quadratic equation, we need this set equal to 0. And so now we hope that we can factor it, but if we can't factor it, why, we can use the quadratic formula. So we've got x plus 10 and x minus 4 work out. X equals negative 10. I'm not afraid of that negative answer, because when you plug in negative 10 and get negative 7, you're squaring it and get a positive 49. So I can take the log of 49. And we also have x equals 4. So both of these are solutions to that equation. Let's go ahead and do the next one. So again, here we have a log equation. On the left-hand side, we have a base 3 and a base 3, so we can apply our properties of logarithms. We have the quotient rule, that if I have the difference of two logarithms, I can write that as a single logarithm by using division. So this 2x plus 7 will appear in a numerator, and this x in a denominator. And now, although I can rewrite the number 2 as log base 3 of 9, it's probably easiest to recognize, hey, this is in log form. I'm going to convert it to exponential form. That the base is 3, a logarithm equals an exponent, and that I have this proportion that 2x plus 7 over x is equal to 9. I'll make 9 a fraction, and if I cross multiply, that seems to be the technique that people prefer most in solving this. So when you have a ratio equal to a ratio, that's a proportion. One technique is to cross multiply. If we multiply along this diagonal and then multiply along that diagonal and set those products equal to each other. So 3 squared is 9, and 9 times x is 9x. And 2x plus 7 times 1, well, hey, that's just the 2x plus 7. So it's easy to see here that x is equal to 1, because you can see that 2 plus 7 is 9. Now, when we plug in 1, yeah, over here we've got the log of a positive value, here the log of a positive value. We're good. That's the equation. That is not extraneous. So hope that helps, and I'll do the next pair in another video.